sedimentary structures and their significance. So first, let's start by identifying sedimentary structures. Sedimentary structures are features that form in sediments and sedimentary rocks at the time of deposition. They provide valuable information about the processes that formed and the rock and the environment where it formed. So first, let's start with common sedimentary structures. The first one is mud cracks, which is a pattern of cracks that is usually produced by when the mud dries. These structures can help determine the direction of sediment transport, while load casts can provide information about the sediment's grain size and consistency. Second is a famous also sedimentary structure, which is cross bedding, which is characterized by layers of sediment that are inclined to the stratification in the rock. And it's significant because it provides information about the direction of sediment transport and the deposition environment. The next one is the ripple mark, which is a linear feature that is caused by the action of waves or currents on the sediment, providing insights into the flow characteristics and the deposition environment. The next one here is raindrops, which are small pits or bump found in soft sediment. Mostly they are assumed to be caused by rainfall or water, but in some cases, other agents such as escaping gas bubbles can cause raindrop impressions. The next one is imbrication, which is a stack of large and usually flat glass cobbles, gravels, or mud chips that are aligned in the direction of fluid flow. The class may be stacked in rows with their edges dipping down and flat surfaces aligned to the face of flow. This one also can provide information about the flow of the fluid. The next one is soil marks that are small features found in river deposits. They form at the base of a bed, the soil, and on top of the underlying bed. They can indicate several things about deposition conditions, such as flow direction and stratific up direction. And also we have biogenic sedimentary structures, which are caused by the activity of organisms such as mounds, reefs, and stromatolites. These structures can act as favorable environments for hydrocarbon entrapment. And the final one is fossil tracks and trails, which are traces left behind ancient organisms such as footprints or burrows, providing information about Palean environment and the behavior of ancient organisms. So next is the significance of sedimentary structures in reservoir quality assessment. Sedimentary structures can significantly impact the initial reservoir quality by creating preferential flow patterns in the reservoir. It also can influence parameters like permeability and effective porosity, because a diagnosis process can affect the reservoir quality by changing or altering permeability or porosity and the connectivity of pores. Planar bedding, laminations, stratification features contribute to the stratified planar flow, and permeability barriers or creating pathways enhance the impact of flow behavior within the reservoir. Here is a picture of how the pores can be, or the stages the pores go through, like cementation, dissolution, in the diagnosis process. And next are the petrophysical methods for assessment, or how to assess a reservoir. Various techniques are used, ranging from macroscopic to microscopic methods. Methods include log analysis, petrophysical core analysis, core description, thin section analysis, and scanning electron microscopy. Also, they evaluate reservoirs' potential for hydrocarbon storage and deliverability. Also, they are critical for determining economic viability in sandstone and carbonate reservoirs, and they are capable of addressing challenges in predicting porosity and permeability influenced by sedimentary structures. Next is a role in hydrocarbon entrapment. Sedimentary structures, for example, bedding, plains, cross bedding, marks crucial for hydrocarbon entrapment, influencing porosity, permeability, and fluid flow characteristics in reservoir rocks. It can create peripheral flow paths or barriers, also traps for hydrocarbons. Cross-bedding and ripple marks indicate ancient currents, helping in understanding hydrocarbon migration. And biogenic sedimentary structures, mounds, reefs, can act as favorable sites for hydrocarbon entrapment, as I mentioned earlier. And diagnostic processes like cementation, dissolution, significantly impact the reservoir porosity and permeability. And overall, they are integral to understanding hydrocarbon entrapment, influencing distribution and accumulation within the reservoir. So in conclusion, sedimentary structures are significant indicators that unravel the geological story embedded within rock formations. The significance of sedimentary structures in the assessment of reservoir quality is undeniable. They not only provide insights into depositional environment, but also play a crucial role in influencing the initial reservoir quality and affect reservoir properties like connectivity and permeability and porosity. So that's all from my side. Thank you.
Okay, thank you, Iman, for this presentation. I hope that you've got some good insight about how this, sedimentary texture can affect actually the decision that can be made for petroleum exploration and also development. Okay, so here we are going to have 3 Q&A from the audience. So I'm going to just give you the opportunity to ask. If not, I'm going to select from the audience. Okay, so anyone has any question about the topic? So can you go for the first page?
Yes, 1 second.
Okay, any question? You can direct your question also to the chat box. Okay, so who is this?
I cannot read the chat box because I'm sharing
okay, so make it audio. Just ask. Okay, so if there is no one, I'm going to select one of you.
Can I ask a question, Prof?
Yeah, go ahead, Aziz.
Iman, you mentioned that it helps with the permeability. Can you elaborate more on that, please?
Yes, sure. Diagnosis process can either enhance or degrade the reservoir properties because it alters the porosity and permeability. Because as I mentioned, it creates paths for the fluid to flow. So depending on those paths, the permeability can be affected.
So what do you mean by creating path for the fluid to flow?
Professional paths. Like
what kind of structure that you are referring to?
I mean, 1 second. Yes, like bedding, planes, cross-bedding, and ripple marks.
Okay. So in addition to the description that you made, I just want to highlight this topic that normally we would have some, based on this kind of structures, this structures specifically for the sedimentary one, which is bedding planes and others, this cross bedding will affect the permeability. All of you know that we have normally 2 types of permeability, vertical permeability and the horizontal permeability. Normally, in this case, if we have a cross bedding, and then the type of rocks are shale, there will be some, actually the horizontal permeability, of course, will be more than that. And this will also affect the decision on multilateral and also horizontal drilling. And also for fracturing. For example, if you want to fracture, there will be a good actually decision that you made the fracture between this kind of structures. So this is very important topic that can be addressed in many disciplines in petroleum engineering, starting from drilling and with enhanced oil recovery, and specifically when we say when we abandon also and we want to inject CO2, for example, this kind of structure will be very important in decision making and measurement and verification purposes. Okay, second question.
Hello.
Yeah, Patricia.
Hello, Doctor. I want to ask, what does it mean by preferential flow path? I think
I cannot hear you.
She asked about differential flow path. Where is the
professional flow path?
yes.
Oh yeah, it creates like a different.
Highlight the text. Where is the text that you are referring to?
The second point.
That's the second bullet number. Okay, professional flow path. Okay.
It means like they create different flow paths which affect the fluid flow.
Yeah, actually creating more description. All of you should know that when we do petrophysical evaluation, there will be some flow units. For example, we may have several flow units for a reservoir, So this kind of structures have a significant impact on determining this flow unit. So in each unit is divided based on its characteristics in actually referring to the flow. So how the flow will move through this kind of structures is all depends on its characteristics. For example, what is the mineralogy, what is the texture, what is the size of the grains, and then is there any discontinuity. So that's why this kind of discontinuities or this kind of actually structure will affect greatly our flow. That's why we have this kind of flow unit in reservoir characterization. Okay, great question, Patricia, and also Aziz. So let's go for the last question. Anyone? Okay, so I think we've already times is up for Iman. Thank you very much, Iman, for your presentation.
Thank you, Doctor, for your valuable information.
My comment for you is that you need to, for the pictures, you need to show these images, pictures in good quality, and discuss about this, and just pinpoint the main actually. You could have come up with a classification and include all of this, and then create a link. For example, click on for example, bedding plane, show a picture, and then talk about this picture. So this will be more interactive for the students and for the learning curve. Okay, great. Thank you.
Doctor.
Okay, so let's move to the second presentation.